Welcome back. Hopefully we survived the lambdas lecture. I know it's a lot. In this video, I'm going to show you a built-in function called map, which you can use lambdas with, and it's a pretty common use case for them. Okay, so map is a standard function that accepts at least two arguments, a function to call, so we pass in a function to map, and an iterable, something we can iterate over, lists, strings, dictionaries, tuples, and sets. And what it will do is whatever function we pass in, which is usually a lambda, it will run that lambda for each value in the list or the string or whatever the iterable is. And then it returns a collection at the end. It's called a map object. We'll get into that later. That contains kind of the new version of everything. So here's an example. I have a list called nums. And let's say I want to double every number in that list. Very simple. All I need to do is use map, just like this. And I'm going to make a new variable. I'm going to call it doubles. So I'll save the result and I'll run map. And then there's two arguments. So the second one we want to be nums. So we'll start there. But then the first one is a function. And so we could write a function called double and have it take a single argument and then return 2 times the argument. Or we could use a lambda like this. And I'll just call this, I don't know, x. And then we'll just do 2 or x times 2. It doesn't matter. Just like that. So what this is saying, map takes this function, this lambda, and this nums list. And it's going to call this on every single item in nums. So it's going to start by taking 2 and passing it in and returning 2 times 2, so 4. And then it's going to put that in a new list. Technically, it's not a list. We'll get there. And it's going to do that for every item in nums. And if we did look at doubles, what we get is this map object, which is something we can iterate over. So if we wanted to, we could just do a, for num in doubles, print num, I need parentheses, and we get 4, 8, 12, 16, 20. Or if we run it again, I could just convert doubles to an actual list. And that's what we get here. One thing that's interesting is that these map objects can only be iterated once. So if I look at doubles now, and I tried to do list doubles again, it's empty. And I need to recreate it. But that doesn't matter, because typically what you would do is just turn it into a list like this. List, map, lambda x. Oh, it's such a nightmare of syntax to just look at here. But if we look at doubles now, we get 4, 8, 12, 16, 20. So let me show you another example. This time I have a list of people. And I want to make a new list where we just have, uppercased for the entire name. So uppercase Darcy, Christina, and so on. I could do that pretty easily with map. And you might be thinking you could use a list comprehension, and that is true. I'll talk about that in a moment. But let's start by making a variable just called peeps equals, and then we'll do map. And the first thing we do is a lambda. And we'll take a name, and then the expression will just be name.upper, comma, and then we pass in people. And then we need to turn it into a list. And if you look at what we get, it's a list where every person, every item in that list is now uppercased. So in the slides, I have the same example of just doubling. But then here's something new. We have a list called names, but each item in the list is a dictionary. First and last are the 2 keys. If I wanted to get an end result of just the first names in a list, I could use map. And the lambda, all that it does for a parameter x, so for each one here, the expression is just x first. So the first key give us the value, which is Rusty, Colt, and Blue. And we're doing it on names, so it runs this for every item in names, resulting with this list after we convert it to a list. Okay, so as I did mention, this is a common use case for lambdas. You don't have to use a lambda. We could make a function, let's call it def, and we could do double to go back to what we had earlier. And double takes in x, and it returns x times 2. And then, we can call double on 3, and we get 6. Perfect. So if I recall my nums from way back, we could just do this, map, and then we pass in double. So this is nice and clean looking, but you have to define an individual function every time to do that. And now if I look at list doubles, I get the same result. But at the end of the day, we could have just done this and done it all in a single line with a lambda, because they do the exact same thing. Take in a single number, return x times that, or x times 2, double the number. Same thing here. There's just no name, no intermediate step involved. And we get the same result. Okay, I know it's kind of overwhelming, and we've kind of been skirting around the fact that we can use list comprehension to do the exact same thing. I'm going to talk about that, but not until the next video. So if you have had that thought, hang on to it. It's a rational thing to think, because this is a lot of syntax for something we could achieve without this syntax, without a lambda, without map, and we just use a list comprehension. But we'll get there. So next up, I'm going to show you something called filter, which is very, very similar in the sense that we can use a lambda, but it does something different. It's the worst explanation I've ever given. Anyway, I'll do a better job in the next video.